Introduction to Azure Entra ID Authentication. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Today, we are diving into one of the most critical aspects of cloud security, application authentication using Azure Entra ID, which you might know by its former name, Azure Active Directory. This is the cornerstone of identity and access management in the Microsoft Cloud ecosystem. Think of Entra ID as your organization's digital bouncer. Just like a bouncer at a club checks IDs and decides who gets in, Entra ID verifies the identity of users and applications trying to access your Azure resources. But it is much more sophisticated than that simple analogy suggests. What we will cover today includes the fundamental concepts of Entra ID authentication, how to register applications, implement different authentication flows, manage permissions and consents, and secure your applications using best practices. Whether you are building a simple web app or a complex microservices architecture, understanding these concepts is crucial. I have structured this presentation to take you from the basics all the way to advanced authentication scenarios. We will look at real-world examples, actual Azure CLI commands, and architectural patterns that you can implement immediately in your projects. By the end of this session, you will have a comprehensive understanding of how to properly secure your applications using Entra ID. What is Azure Entra ID? Let me explain what Azure Entra ID really is and why it is so important. Azure Entra ID, formerly known as Azure Active Directory or Azure AD, is Microsoft's cloud-based identity and access management service. It is not just a simple authentication system. It is a comprehensive identity platform that serves as the backbone for security in Azure and Microsoft 365. The key thing to understand is that Entra ID is fundamentally different from traditional on-premises Active Directory. While they share some concepts, Entra ID is built for the cloud from the ground up. It uses modern protocols like OAuth 2.0, OpenID Connect, and SAML, rather than the older Kerberos and NTLM protocols used by traditional AD in the diagram on the slide. You can see how Entra ID acts as a central authentication authority. Users, whether they are employees, partners, or customers, authenticate against Entra ID applications. Both Microsoft's own services like Office 365 and your custom applications rely on Entra ID to verify user identities. External systems can also integrate through various protocols. What makes Entra ID particularly powerful is its ability to handle multiple identity scenarios. It can manage employee identities for your organization, customer identities for your public-facing applications, and even machine identities for service-to-service authentication. This flexibility makes it suitable for virtually any authentication scenario you might encounter in the cloud. The platform also provides advanced security features like conditional access policies, multi-factor authentication, and identity protection. These are not just add-ons. They're integral parts of the platform that help you build a zero-trust security model. Core authentication concepts. Now let's dive into the core concepts that form the foundation of Entra ID authentication. Understanding these concepts is crucial because they'll come up repeatedly as you work with Azure applications. First, we have the application registration. This is essentially your application's identity card in Entra ID. When you register an application, you're telling Entra ID, "Hey, this application exists and might need to authenticate users or access resources." The registration creates an application ID, also known as a client ID, which uniquely identifies your application. Next is the service principal. This is where things get interesting. While the application registration is like a template that exists at the tenant level, a service principal is the actual instance of that application in a specific Azure AD tenant. Think of it this way. If the application registration is a class definition, the service principal is an object instance of that class. This distinction becomes important when you're dealing with multi-tenant applications. The authentication flow refers to the specific process by which authentication happens. There are several flows, each suited to different scenarios. The authorization code flow is used for web applications. The implicit flow, now deprecated, was used for single-page applications, and the client credentials flow is used for service-to-service authentication without user interaction. Scopes and permissions define what your application can do once it's authenticated. Scopes are typically used with delegated permissions, acting on behalf of a user, while application permissions are used when the app acts on its own behalf. For example, user.read might allow reading the signed-in user's profile, while user.read.all with application permissions could read all users in the directory. Finally, tokens are the currency of authentication in Entra ID. You'll work with ID tokens, which contain information about the authenticated user, access tokens, which are used to call APIs, and refresh tokens, which can be used to get new access tokens without re-authenticating. Understanding the lifecycle and proper handling of these tokens is essential for building secure applications. Registering an application in Entra ID. Let's walk through the process of registering an application in Entra ID using the Azure CLI. This is typically the first step when you are building any application that needs to authenticate users or access Azure resources. The command I am showing you here, AZ-app create, is the starting point. The display name parameter is straightforward. It is just the friendly name that appears in the Azure portal. But the sign-in audience parameter is crucial. This determines who can use your application. Azure AD My.org means only users in your tenant can sign in. Azure AD Multiple Orgs allows users from any Azure AD tenant, and Azure AD and personal Microsoft account includes personal Microsoft accounts like Outlook.com. The web redirect UR is parameter specifies where Entra ID can redirect users after authentication. This is a security feature. Entra ID will only redirect to URLs you have explicitly registered. For development, you will often use localhost URLs, but in production, these should be your actual application URLs. You can specify multiple redirect URLs if your application has multiple entry points. When you run this command, it returns a JSON object with important information. The app ID is your client ID. You will need this everywhere. It is like your application's username when talking to Entra ID. The ID is different. It is the object ID of the application registration itself, used for management operations. After creating the app registration, you typically need to create a client secret or certificate for authentication. The command AZ-app credential reset generates a new client secret. This is like your application's password. The critical thing to remember is that the secret value is only shown once. You cannot retrieve it later. Store it securely in a key vault or secure configuration immediately. The commands also show how to retrieve and update your application registration. The AZ-app show command is useful for verifying your configuration, while AZ-app update allows you to modify settings like adding new redirect URLs or changing the display name. In real-world scenarios, you will often need to update these settings as your application evolves. Authentication flows in Entra ID. Understanding authentication flows is absolutely critical for building secure applications. Each flow is designed for specific scenarios, and choosing the wrong one can either compromise security or create a poor user experience. Let me walk you through the main flows you will encounter. The authorization code flow is the gold standard for web applications. Here's how it works. First, your application redirects the user to Entra ID's authorization endpoint. The user logs in there, not in your application. This is important because your application never sees the user's password. After successful authentication, Entra ID redirects back to your application with an authorization code. This code is like a voucher. It's short-lived and can only be used once. Your application then exchanges this code for tokens by making a backend call to Entra ID. This exchange includes your client secret, proving your application's identity. The client credentials flow is completely different. There's no user involved at all. This is for service-to-service authentication. like when your backend API needs to call another API. Your application authenticates directly using its client ID and secret. This flow is perfect for background jobs, daemon applications, or any scenario where you need to authenticate as the application itself, not on behalf of a user. The device code flow is fascinating and solves a specific problem. How do you authenticate on devices that do not have a web browser or have limited input capabilities? Think smart TVs or IoT devices. The device displays a code to the user and tells them to visit a URL on another device. The user enters the code there and completes authentication. Meanwhile, the device polls Entra ID to check if authentication is complete. The diagram shows how tokens flow differently in each scenario. Notice how in the authorization code flow, the tokens never pass through the user's browser. They go directly from Entra ID to your backend. This is a key security feature. In contrast, the client credentials flow is much simpler because there's no user redirection involved. One critical point. The implicit flow, which you might see in older documentation, is now deprecated. It was designed for single-page applications but had security limitations. Modern SPAs should use the authorization code flow with PKCE, proof key for code exchange, instead. This provides better security without requiring a client secret in the browser. Implementing authorization code flow. Let me show you exactly how to implement the authorization code flow, which is the most common scenario for web applications. I will break down each step with the actual URLs and parameters you need. Step 1 is constructing the authorization URL. Look at the URL structure carefully. The base URL is https://login.microsoft.online.com/tenant/oauth2/v2.0/authorize. You replace tenant with your tenant ID or domain name. The client ID is your application's ID from the registration. The response type equals code tells Entra ID you want an authorization code, not tokens directly. The redirect URI must exactly match one of the URIs you registered. Even a trailing slash difference will cause an error. The scope parameter is interesting. OpenID is required for OpenID Connect. Profile gives you access to basic user information, and user.read is a Microsoft Graph scope. You can request multiple scopes separated by spaces. The state parameter is crucial for security. You generate a random value, include it in the request, and verify it matches when the user returns. This prevents CSRF attacks. I recommend using a cryptographically secure random generator and storing the state in the user's session. Step 2 happens at Entra ID. The user sees Microsoft's login page, enters their credentials, and possibly completes MFA if this is the first time. They will also see a consent screen listing the permissions your app is requesting. After successful authentication, Entra ID redirects to your redirect URI with the code and state parameters. Step 3 is the token exchange. This must happen on your backend. Never expose your client secret in client-side code. The POST request to the token endpoint includes the authorization code you received. The grant type must be authorization code. Include the same redirect URI you used in step 1. This is for validation, not for actual redirection. The response contains several tokens. The access token is what you will use to call APIs. It is typically valid for 1 hour. The ID token contains information about the authenticated user. You can decode this JWT to get the user's name, email, and other claims. The refresh token is long-lived and can be used to get new access tokens without user interaction. Store all tokens securely and never expose them to client-side JavaScript. Working with permissions and scopes. Permissions and scopes are fundamental to Entra ID's security model, and understanding the distinction between delegated and application permissions is crucial for building secure applications. Let me explain how these work and when to use each type. Delegated permissions are used when your application acts on behalf of a signed-in user. The effective permissions are the intersection of what the user can do and what your app is allowed to do. For example, even if your app has user.read.all delegated permission, a regular user can still only read their own profile, not all users. The command shown uses user.read, which allows reading the signed-in user's profile, and mail.read, which allows reading their email. Application permissions are completely different. These are used when your application acts as itself, with no user context. This is typically for background services or daemon applications. With user.read.all as an application permission, your app can read any user's profile in the directory. This is obviously very powerful, which is why application permissions always require admin consent. The consent process is worth understanding in detail. For delegated permissions, if they are low privilege, like reading the user's own profile, users can consent themselves. But for high privilege permissions or any application permissions, an administrator must consent. The command AZ-700 app permission grant shows how an admin can pre-consent to permissions, which means users will not see a consent prompt. When adding permissions using the Azure CLI, you need to know the correct IDs. The example shows the Microsoft Graph API's application ID. Each permission also has a unique ID. For example, the ID for the user.read permission is provided. You can find these IDs in the Azure portal, or by using the AZ-700 show command with the application ID and querying for app roles. A critical point about application permissions: they continue to work even after the user who set them up leaves the organization. This is both a feature and a risk. It is a feature because your background services keep running, but it is a risk because there is no user to hold accountable. Always audit application permissions regularly and follow the principle of least privilege. Token management best practices. Token management is where security theory meets practical implementation. Get this wrong, and you have essentially left your front door open. Let me share the critical practices that will keep your applications secure. First, let's talk about token storage. Never, ever store tokens in local storage or session storage in web browsers. These are accessible to any JavaScript code, including malicious scripts. For SPAs, consider using in-memory storage and refresh tokens with rotation. For server-side applications, store tokens in secure session stores, preferably encrypted at rest. Token validation is non-negotiable. When you receive an ID token, you must validate its signature, issuer, audience, and expiration. The issuer should be https://login.microsoftonline.com/tenant/v2.0. The audience should be your application's client ID. Do not just check if the token is syntactically valid. Verify it was actually issued for your application. Access token usage requires careful handling. These tokens are bearer tokens. Anyone who has the token can use it. Always use HTTPS, never log tokens in production, and include tokens only in the authorization header, not in URLs where they might be logged or cached. The format is always authorization, bearer token. The refresh token pattern shown in the diagram is crucial for user experience. Access tokens typically expire after 1 hour. Instead of forcing users to log in again, use the refresh token to get a new access token. But here is the key. Refresh tokens should be used sparingly and protected even more carefully than access tokens. They are long-lived and can be used to get new access tokens without user interaction. When refreshing tokens, implement proper error handling. If the refresh fails with an invalid grant error, it usually means the refresh token has been revoked or expired. Do not retry indefinitely. Redirect the user to sign in again. Also, implement token caching to avoid unnecessary token requests. But remember to invalidate the cache when tokens expire. For production applications, consider implementing token binding or proof of possession mechanisms for additional security. Monitor for anomalous token usage patterns. Multiple simultaneous uses of the same token from different locations could indicate token theft. Multi-tenant authentication is where Entra ID really shines, enabling you to build SaaS applications that can authenticate users from any Azure AD tenant, not just your own. This is how Microsoft's own services like Office 365 work. One application serving millions of users across thousands of organizations. The key difference starts at app registration. By setting Sign in Audience Azure AD multiple orgs, you're telling Entra ID that users from any Azure AD tenant can authenticate. But this is just the beginning. Your application needs to be designed to handle users from different organizations. When a user from another tenant signs in for the first time, they will see a consent prompt. If your app requires application permissions or admin restricted delegated permissions, their administrator will need to consent. This is typically done through an admin consent flow, where you add and prompt equal operator admin consent to your authorization URL. The technical implementation has important nuances. In multi-tenant apps, you cannot validate the issuer against a specific tenant ID because users come from different tenants. Instead, you validate against the common issuer. https://login.microsoftonline.com/tenant-id/v2.0. The tenant ID in the token tells you which organization the user belongs to. Data isolation is critical in multi-tenant applications. You must ensure that users from one tenant cannot access another tenant's data. The typical pattern is to use the tenant ID from the token as a key in your database schema. Every query should filter by tenant ID. Some developers use separate databases per tenant for additional isolation. The service principal in each tenant is created automatically when the first user consents. This service principal represents your application in that tenant. Administrators can manage it like any other application. They can revoke access, configure conditional access policies, or assign it to specific users. Here is a pro tip. Implement a tenant onboarding flow. When a new organization signs up, capture additional information like billing details and configuration preferences. Store this in your database linked to their tenant ID. This allows you to provide a customized experience per organization while using the same application registration. Conditional access integration. Conditional access is Entra ID's policy engine that brings together signals, makes decisions, and enforces organizational policies. Think of it as smart, context-aware access control that goes far beyond simple username and password authentication. The beauty of conditional access is that it works transparently with your application. You don't need to modify your code to benefit from it. Administrators configure policies in Entra ID, and they're automatically enforced when users authenticate to your application. However, your application does need to handle certain scenarios gracefully. Let's walk through the signal examples. User identity and group membership are straightforward. Policies can target specific users or groups. Location-based policies can require MFA when users sign in from untrusted locations. Device compliance ensures that only managed and compliant devices can access your application. Risk signals come from Entra ID protection, which uses machine learning to detect suspicious sign-in patterns. The decision process evaluates all applicable policies. If multiple policies apply, the most restrictive combination is enforced. For example, if one policy requires MFA and another blocks access, the user is blocked. This ensures security policies can't be bypassed by finding a less restrictive path. Access controls are where policies take action. Requiring MFA is the most common control. Requiring device compliance ensures only corporate managed devices access sensitive applications. Device-based controls can require domain-joined or Intune-enrolled devices. Session controls are particularly interesting. They can limit what users can do even after successful authentication, like preventing downloads or limiting session lifetime. Your application needs to handle claims challenges. When a conditional access policy requires additional verification, Entra ID returns a claims challenge to your application. You must pass this back to the authorization endpoint, which triggers the required action. Like MFA after the user completes the challenge, they're redirected back with a new authorization code. For testing, use the What If tool in the Azure portal. It simulates policy evaluation without actually enforcing policies, helping you understand which policies would apply in different scenarios. This is invaluable for troubleshooting access issues and planning policy changes. Security best practices. Security and application authentication is not just about following a checklist. It is about understanding the threat landscape and implementing defense in depth. Let me share the critical security practices that will protect your applications from common attacks. Using HTTPS everywhere seems obvious, but it is worth emphasizing. Every single communication with Entra ID must use HTTPS. This includes redirect URIs, token endpoints, and API calls. In development, use proper certificates even for localhost. Tools like Mixert make this easy. Never disable certificate validation, even in development. This creates bad habits that might slip into production. Implementing PKCE, proof key for code exchange, is no longer optional for public clients like SPAs and mobile apps. PKCE prevents authorization code interception attacks. Your app generates a random code verifier, hashes it to create a code challenge, includes the challenge in the authorization request, and then provides the verifier when exchanging the code for tokens. This proves that the same application that initiated the request is completing it. Secure token storage varies by application type. For web applications, store tokens in encrypted session cookies with the HTTP only, secure, and same site flags. For SPAs, avoid storing tokens in any persistent storage. Use in-memory storage and implement silent token renewal. For mobile apps, use platform-specific secure storage like iOS Keychain or Android Keystore. Regular security audits should be automated where possible. Use Azure CLI or PowerShell scripts to regularly review app permissions, especially application permissions. Look for apps with high privilege permissions that have not been used recently. Check for apps registered by users who have left the organization. Monitor for apps with credentials approaching expiration. Least privilege principle applies at multiple levels. Request only the permissions your app actually needs. Use delegated permissions instead of application permissions where possible. If you need application permissions, consider if you can achieve the same goal with less privileged permissions. For example, instead of user.read.all, perhaps you only need user.read.basic.all. Monitor authentication logs through Azure AD's sign-in logs and audit logs. Look for patterns like repeated failed authentications, sign-ins from unusual locations, or impossible travel scenarios. Set up alerts for high privilege permission grants or changes to application permissions. These logs are your early warning system for potential security issues. Troubleshooting common issues. Let me share the most common authentication issues you will encounter and, more importantly, how to fix them. These errors can be frustrating, but understanding what they mean makes troubleshooting much easier. The invalid client error. AZ-7000215 usually means there is a mismatch between your client ID and secret. First, verify you are using the correct client ID. It is easy to mix up the application ID and object ID. Check that your client secret has not expired. They are only valid for the duration you specified. If you are copying the secret, make sure you are not including extra spaces or missing characters. Remember, you only see the secret value once when creating it. Redirect URI mismatch. AZ-700 is probably the most common error during development. The URI in your authorization request must exactly match one registered in your app. This includes the protocol, HTTP versus HTTPS, port number, and path. Even a trailing slash matters. During development, if you are using localhost :3000, make sure that exact URI is registered. For production, register all variations your app might use. Consent errors come in various forms. Need admin approval means the permissions you are requesting require administrator consent. You have two options. Ask an admin to consent using the admin consent endpoint, or reduce your permission requirements. Sometimes users see AADSTS 65001 which means the user or admin has not consented to your app. This often happens in multi-tenant scenarios where each tenant needs to consent separately. Token validation failures are often silent. Your API just returns 401 unauthorized. Common causes include expired tokens. Check the express claim. Wrong audience. The token was issued for a different application, or invalid signature. Usually means you are validating against the wrong key. Use JWT.ms to decode tokens during debugging, but never paste production tokens into online tools. MFA and conditional access errors require special handling. When you get AADSTS 50076 or AADSTS 53003, it means a conditional access policy is blocking access. Your application needs to handle the claims challenge and redirect the user back to entra ID with the claims parameter. After they complete the required action, they will be redirected back to continue the authentication flow. For systematic debugging, enable detailed logging in your application. Log the full authorization URL. Without secrets. The full error response from entra ID, and the decoded token claims. Use correlation IDs from error messages when contacting support. They can trace the exact authentication attempt through the system. Advanced scenarios. Service-to-service authentication. Service-to-service authentication involves moving us beyond user-centric scenarios into the realm of autonomous applications. This is critical for microservices architectures, background jobs, and any scenario where applications need to communicate without human intervention. The foundation is the client credentials flow. Your application authenticates using its own identity, not on behalf of a user. The key difference is that there is no interactive authentication. Your service presents its credentials directly to entra ID and receives an access token. This token represents the application itself. Creating a client secret is straightforward with the Azure CLI command shown. But here is what is important. Treat this secret like a password to your production database. Store it in Azure Key Vault, not in your application configuration. Use managed identity where possible to eliminate secrets entirely. If you must use secrets, rotate them regularly. I recommend at least every 90 days. The token request for client credentials is simpler than user flows because there is no redirect dance. Your application makes a direct post request to the token endpoint. The scope parameter is interesting here. You use the resource's application ID URI followed by .default. This requests all permissions that have been granted to your application for that resource. Certificate-based authentication is the more secure alternative to client secrets. Instead of a password, your application proves its identity using a certificate. The process involves creating a self-signed certificate, or better, using a certificate from your organization's CA, uploading the public key to your app registration, and using the private key to sign the authentication request. This is more complex to set up but eliminates the risk of secret exposure. The real power comes when you combine this with managed identity. Instead of managing credentials at all, your Azure resources get an automatically managed identity. Your app service, function, or virtual machine can get tokens without any secrets in your code. The Azure infrastructure handles credential rotation and security for you. This is the gold standard for service-to-service authentication in Azure. For cross-tenant scenarios, you might need to authenticate to resources in other tenants. This requires setting up a multi-tenant app registration and having the target tenant's administrator consent to your application. The authentication process is similar, but you will use the target tenant's endpoint rather than your home tenant. Managed Identity Deep Dive. Managed Identity is one of Azure's most elegant solutions to the authentication problem. It completely eliminates the need for credentials in your code, which is a massive security win. Let me explain how this works and why you should use it whenever possible. There are two types of managed identities. System-assigned identities are tied to a specific Azure resource. When you enable it on an app service, for example, Azure creates an identity that lives and dies with that app service. If you delete the app service, the identity is automatically deleted too. This tight lifecycle management prevents orphaned identities. User-assigned identities are standalone resources that you create separately and then assign to one or more Azure resources. This is useful when you have multiple resources that need the same permissions, or when you want to set up permissions before creating the resources. You might use this pattern in infrastructure as code scenarios where you want deterministic identity management. The beauty is in the token acquisition. Your code simply calls the Azure Identity Library, and it automatically gets tokens from the Azure infrastructure. No secrets, no certificates, no configuration. The token endpoint is available at a special non-routable IP address 169.254.169.254 that's only accessible from within the Azure resource. This endpoint is protected by the Azure Fabric itself. The Azure CLI commands show how to assign permissions to managed identities. First, you get the identity's principal ID. This is like the identity's username in Entra ID. Then you assign roles just like you would to any user or service principal. The identity can access exactly what you've granted it access to, nothing more. Here's what makes this particularly powerful. The identity tokens are automatically rotated by Azure. You don't worry about expiration or renewal. The tokens are cached appropriately by the Azure Identity Library. Network calls to get tokens are minimized, but you always get valid tokens. Common use cases include accessing key vault secrets, calling Microsoft Graph API, accessing storage accounts, or connecting to SQL databases. In each case, you're eliminating credentials from your code. This dramatically reduces your attack surface. There are no secrets to accidentally commit to source control or expose in logs. Monitoring and auditing authentication events is not just about compliance. It is about understanding how your applications are being used and detecting potential security issues before they become incidents. Entra ID provides rich logging capabilities, but you need to know how to use them effectively. Sign-in logs are your first line of defense. Every authentication attempt is logged, whether successful or failed. The Azure CLI command I am showing filters for failures, but you can query by user, application, date range, or any combination. Each log entry contains valuable information: the user, application, IP address, location, device information, and any conditional access policies that were evaluated. What should you look for? Failed sign-ins are obvious, but patterns matter more than individual events. Multiple failed attempts from the same IP might indicate a brute force attack. Successful sign-ins from unusual locations could indicate compromised credentials. Look for impossible travel scenarios. A user signing in from New York and Tokyo within minutes. Audit logs capture administrative actions. Every change to your application registrations, permission grants, and directory configuration is logged. This creates an immutable audit trail. Pay special attention to high privilege permission grants, new application registrations, and changes to conditional access policies. These logs answer the critical question: who changed what, and when? For real-time analysis, stream these logs to Azure Monitor, Sentinel, or your SIEM solution. Set up alerts for critical events, application permission grants, admin consent actions, or unusual patterns of failed authentications. Do not wait for quarterly security reviews to find issues. Detect them as they happen. Log retention is important for compliance and forensics. By default, Azure AD retains logs for 30 days, 7 days for free tenants. For longer retention, configure diagnostic settings to send logs to a log analytics workspace or storage account. Consider your compliance requirements. Some regulations require years of retention. Create custom workbooks in Azure Monitor for authentication dashboards. Track metrics like authentication success rate by application, most common failure reasons, and authentication patterns over time. This helps you identify both security issues and user experience problems. If an application suddenly shows increased failures, you can investigate before users start calling support. Cost optimization strategies. While intra-ID pricing might seem straightforward, there are several strategies to optimize costs without compromising security or functionality. Let me share approaches that can significantly reduce your authentication costs, especially at scale. First, understand the pricing model. Intra-ID has different tiers: free, P1, and P2. The free tier includes authentications per month and basic features. This is often sufficient for small applications or proof of concepts. P1 adds conditional access, which is essential for enterprise applications. P2 includes advanced identity protection features. Choose the tier based on your actual security requirements, not just because it's available. Token caching is crucial for cost optimization. Every authentication request counts against your quota and potentially incurs cost. Implement proper token caching on both client and server sides. Access tokens are typically valid for 1 hour. Don't request new tokens for every API call. Use refresh tokens appropriately to get new access tokens without re-authenticating the user. Application architecture impacts costs. Instead of having every microservice authenticate independently, consider using an API gateway pattern. The gateway handles authentication once and passes validated claims to backend services. This reduces the number of token validations and improves performance. For multi-tenant applications, be strategic about permission requests. Each tenant admin consent is essentially free, but the ongoing authentications count. If you're building a SaaS application, consider implementing your own session management on top of intra-ID authentication. Authenticate users once with intra-ID, then manage sessions in your application to reduce repeated authentications. Monitor your usage carefully. Use Azure Cost Management to track intra-ID costs. Set up budgets and alerts before you hit limits. The metrics shown in the diagram help identify optimization opportunities. If you see high authentication rates from specific applications or users, investigate why. Maybe there's a token caching issue or an application making unnecessary authentication requests. Consider alternatives for specific scenarios. For public-facing websites with millions of users who only need basic authentication, intra-ID B2C might be more cost-effective. For internal applications, ensure you're not over-provisioning licenses. Not every user needs P2 features. Use group-based licensing to assign premium features only to users who need them. Migration strategies. Migrating authentication systems is one of the most delicate operations in IT. You're changing how users access applications while maintaining security and minimizing disruption. Let me walk you through proven strategies for migrating to intra-ID from other authentication systems. The phased migration approach is almost always the right choice. Start with a pilot group, typically IT staff or a small department that can tolerate some disruption. This lets you identify issues before they affect the entire organization. Gradually expand to more users and applications, monitoring carefully at each stage. User migration requires careful planning. If you're coming from on-premises Active Directory, Azure AD Connect synchronizes users automatically. For other systems, you might need to bulk import users. The Azure CLI command shown creates users programmatically. Pay attention to user principal names. They must be unique across your tenant. Consider using a staging attribute to track migration status. Application migration is where complexity lives. Start by inventorying all applications and their authentication methods. Modern applications using SAML or OAuth are usually straightforward to migrate. Legacy applications might require Azure AD Application Proxy or significant refactoring. Create a migration priority matrix based on user count, business criticality, and technical complexity. The parallel run period is crucial. Run both authentication systems simultaneously, allowing users to authenticate through either system. This provides a fallback if issues arise. Use claims transformation to ensure both systems provide compatible user information to applications. Monitor which system users prefer. This often reveals usability issues. Data migration goes beyond just users. Preserve group memberships, which often control application access. Migrate application-specific roles and permissions. Don't forget about service accounts. These often run critical background processes. Document all accounts and their purposes before migration. Communication is vital throughout the migration. Users need to know what's changing, when it's changing, and what they need to do. Provide clear documentation and training. Set up a dedicated support channel for migration issues. Consider gamification or incentives to encourage early adoption. Most importantly, have a rollback plan. Despite careful planning, issues can arise that require reverting to the original system. Future-proofing your authentication. Authentication technology evolves rapidly, and what's considered best practice today might be obsolete tomorrow. Let me share strategies to ensure your authentication architecture remains secure and modern as the landscape changes. Passwordless authentication is the future, and Entra ID is already there. Windows Hello for Business, FIDO2 security keys, and the Microsoft Authenticator app enable users to sign in without passwords. This isn't just about user convenience. It's about eliminating the weakest link in security. Passwords can be phished, stolen, or guessed. Passwordless methods are inherently more secure. Continuous authentication is an emerging pattern where trust is constantly evaluated, not just at sign-in. Entra ID's Continuous Access Evaluation, CAE, is an early implementation. It can revoke access in near real-time when conditions change, like when a user leaves the organization or a device becomes non-compliant. Design your applications to handle token revocation gracefully. Verified ID represents a fundamental shift in identity. Instead of each application maintaining user profiles, users bring their verified credentials. Think of it like showing your driver's license. The DMV verified your identity, and others trust that verification. This could dramatically simplify user onboarding while improving privacy. Decentralized identity goes even further. Users own their identity data and selectively share it with applications. This aligns with privacy regulations and user expectations. While still emerging, the standards are stabilizing. Consider how your applications might work in a world where users, not corporations, control identity data. API security is becoming inseparable from user authentication. Modern applications are API first, and securing these APIs requires sophisticated authentication patterns. Look at standards like OAuth 2.0 demonstration of proof of possession, DPoP, which binds tokens to clients more strongly than bearer tokens. To future-proof your implementation, follow these principles. Use standard protocols, not proprietary solutions. Abstract authentication logic from your application code. Stay informed about emerging standards through the OpenID Foundation and IETF. Participate in preview programs for new Entra ID features. Most importantly, design for change. Authentication requirements will evolve, and your architecture should accommodate new methods without wholesale rewrites. Integration patterns and code samples. Let me show you practical integration patterns that you can implement immediately in your applications. These patterns have been battle-tested in production environments and follow security best practices. The ASP.NET core integration is streamlined through Microsoft's authentication middleware. The configuration in your program.cs file sets up the authentication pipeline. Notice how we're validating both the token issuer and audience. This ensures tokens are from the expected tenant and for your application. The save token equals true option stores the access token for later use when calling downstream APIs. For Node.js applications using Express, the pattern is similar but requires more explicit configuration. The MSAL Microsoft Authentication Library handles the heavy lifting of token acquisition and caching. The key is properly configuring the redirect URLs and scopes. The session configuration is crucial. In production, use a proper session store like Redis, not memory storage. React applications present unique challenges because they run in the browser. The MSAL React library provides hooks that integrate cleanly with React's component lifecycle. The Use MSAL hook gives you access to authentication methods, while Use as authenticated helps with conditional rendering. Always use the authorization code flow with PKCE for SPAs, never the deprecated implicit flow. Python Flask applications benefit from the MSAL Python library. The pattern involves setting up routes for login and authorization callbacks. The library handles the OAuth dance, but you need to properly manage sessions. Store tokens in server-side sessions, never send them to the client. A PI integration requires validating tokens on every request. The middleware examples show how to extract the bearer token, validate its signature and claims, and make the user's identity available to your application logic. For high-performance scenarios, implement token validation caching, but be careful to respect token expiration times. Summary and next steps. We've covered a comprehensive journey through Azure Entra ID authentication, from basic concepts to advanced implementation patterns. Let me summarize the key takeaways and provide you with actionable next steps to implement secure authentication in your applications. The fundamental concepts we covered, application registrations, service principals, authentication flows, and token management, form the foundation of every Entra ID integration. Remember that choosing the right authentication flow for your scenario is crucial. Web apps use authorization code flow, services use client credentials, and modern SPAs use authorization code with PK-circa-E. Security isn't optional, it's fundamental. Always use HTTPS, implement proper token storage, follow the principle of least privilege, and regularly audit your permissions. Managed identities eliminate credentials from your code entirely. Use them whenever possible for Azure resources. Your immediate next steps should be: first, if you have existing applications using outdated authentication methods, create a migration plan. Second, audit your current application permissions. Remove any that aren't actively used. Third, implement proper monitoring and alerting for authentication events. Fourth, enable managed identities for your Azure resources to eliminate credentials. For continued learning, explore the Microsoft Identity Platform documentation for deep dives into specific scenarios. The Azure ADB2C service offers additional capabilities for customer-facing applications. Stay informed about new features through the Azure Updates feed and Microsoft Identity Platform blog. Remember that authentication is just the first step. Authorization, determining what authenticated users can do, is equally important. Consider implementing a proper authorization strategy using Azure RBAC or custom claims-based authorization in your applications. Thank you for your attendance. Please consider subscribing to the channel.